Here's another absolute value problem. It's got a little bit more going on around it than what we would like. So in order to solve an absolute value problem, what you want to think about is you want to, first of all, get the absolute value alone. Okay? You want to get the absolute value alone, you want to get it by itself. So let's just review some algebra. Let's just pretend that this is 3 times some number minus 1 equals 8. Okay? Notice how I simplified it. I'm pretending n is equal to the absolute value of x plus 2. So if I were to put x plus 2 in place of n, I get the same exact equation. We know how to do this. We're doing PEMDAS backwards, so we're going to add 1 to each side. So that gives us 3n is equal to 9, and then we divide each side by 3, so then we end up getting n equals 3. Okay, that was easy enough. So, but we're going to do the same sort of thing here, except instead of having n, it's going to be the absolute value of x plus 2. Let's see what I'm talking about. Maybe this will make a little bit more sense once I do it. So remember, our goal is initially to get the absolute value alone. Okay? So that means that I have to get either the 3 or the negative 1 out of there. So do you remember with PEMDAS, what did we say? We said if we're simplifying, we go this way. If we're solving, we go backwards. Remember, we are solving for x, so we're going to go backwards. X is stuck inside the absolute value right now, and that's what we want to get by itself, the absolute value. So notice I have a negative 1 here. I'm going to rewrite this problem, which is a habit you should always get into as well. So I want to get this alone right here by itself. That means I'm going to add 1 to both sides because I have something being added to what I'm trying to solve for. So that means that this gives me 3 times the absolute value of x plus 2 equals 9. So I want to get this by itself. So remember PEMDAS, we have something that's being multiplied to what we're solving for. In this case, it's the absolute value. So that means I unmultiply, so I'm going to divide by 3. So that gives me the absolute value of x plus 2 equals 3. So now I have my absolute value all by itself. Okay. So if we remember from our investigation of number lines, let's look at what this might mean as far as a number line is concerned. So I'm going to just put my number line, I guess maybe I'll put it underneath here. What does this mean? So notice I haven't solved anything yet. We will solve it. Okay, this means this 3 means distance, doesn't it? That's my distance away from whatever my center point is. Well, my center point happens to be the opposite of what I see here. So that's going to be, what's the opposite of 2? Negative 2. So I'm going to go a distance of 3 to the right. 1, 2, 3. So it's negative 1, 0, 1. And I'm going to go 3 to the left. 1, 2, 3. So that would be -3, -4, -5. So when I solve this algebraically, my answer should be -5 and 1. Or I correctly said -5 or 1. Okay, so let's go ahead and let's solve this in its two cases. But first I want to emphasize, notice I had to get my absolute value by itself first. Okay, so I'm going to go ahead and fold my paper so that I'm only showing this equation, because that's what we solved this one here on the top to be. Okay, so now I'm going to have case 1, and I'm going to have case 2. So remember, for case 2, I want to think the absolute value of whatever's in here has to equal 3. Well, that's the same as 3 equals 3, right? For case 2, I'm going to think the absolute value, in this case, -3 equals 3. Okay? So remember that this is inside my absolute value. This is inside my absolute value. So that's going to make this x plus 2. Well, that must equal 3 for case 1. This is inside my absolute value. This is inside my absolute value. So that means I also have x plus 2 equals -3. So we're going to continue using PEMDAS backwards, and we're going to solve these. They're pretty straightforward. So this is -2 on both sides. So look what I got. I got x equals 1. That's what I got on my number line. That must be right. Now I'm going to subtract 2 on both sides for my case 2 problem. So that means I have x is equal to -5. Look at that. I got that on my number line when I thought of this as distance from center. So both of those are correct. And look, I already graphed my number line, so I don't have to graph it again. And I am done with that problem.